Hi folks, Mr. Long here. I'm going to do a screencast today on oblique asymptotes. And what we're going to do is we're going to start with a function like this right here that you can see. I'm using my mouse to circle around it, 8x squared minus 3x plus 1 divided by x minus 2. And we want to come up with the oblique asymptote. And the first thing is, well, why do we know it's an oblique asymptote? Well, I've got 8x squared on the top and I've got x on the bottom. And we know that the oblique asymptote is just another form of end behavior asymptote. It's like a horizontal asymptote. And if I think of when x approaches infinity, that negative 3x is going to be very close to 0, and that plus 1 is going to be very close to 0. Like relative, sorry, won't be 0. Relative, it's insignificant relative to the 8x squared. Similarly, the negative 2 is small, insignificant compared to x, as when x is like a billion. So overall, we end up with 8x squared over x. Okay, 8x squared over x, which is 8x. So we know that globally, the oblique asymptote is 8x. But locally, so if I look over at the graph, locally, if it's 1, 2, 3, 10, that is significant here. It's not significant when we're way, way out to the right or way, way down here to the left, but locally it is significant. So for drawing a sketch, sometimes, most of the time, it makes sense that we get the oblique asymptote. Okay, so this method, there's many methods. We're just going through one for now. So we're going to use this relationship. The n over d equals q plus r over d. And then when you multiply both sides by d, you end up with this. Now, here's a specific example right here. Okay, here's a specific example. And that specific example, I think, will help you understand this relationship. So here's our function, right? And what we want to do is we want to represent it as q plus r over x minus 2. And we remember, hopefully from class, that q is the oblique asymptote. Okay, the oblique asymptote. So we take this format here, we multiply both sides by x minus 2, and we end up with q, which is 8x plus b. Why do we know it's 8x? Because 8x squared over x is 8x. So 8x plus b times by x minus 2 plus the remainder, okay, is our function on the right side. And on the left side, we've got 8x squared minus 3x plus 1. So we know that this right here, the left side, has to be equal to the right side. And the only thing on the right side that's going to create x terms is these two binomials being multiplied together, right? So on the left side, the x terms, there are negative 3 x terms. On the right side, we've got to figure that out. So how do I generate x terms on the right side? Well, 8x multiplied by negative 2 will give me negative 16x's. And then this b, which is a constant, multiplied by x will give me bx, or bx terms. Okay, so I can just solve it from there, because what value of b do I need to have negative 3 on the left side? Well, negative 16 plus some number is negative 3. Well, I'm pretty sure, which becomes negative 3 equals negative 16 plus b. B equals 13. You don't need to show any work to do that, right? You just know that negative 16, plus 13 is negative 3. Whoa, I probably should have my glasses on when I'm doing this. Anyway, so we know what b is. B is 13, and that tells us our oblique asymptote is 8x plus 13. So I know, think about 8x plus 13. What would the x-intercept be for that line? Well, it'll be negative 13 divided by 8, which is between negative 1 and negative 2. You don't have to have ticks on your grid when you do this, but so I know it's going to have a positive y-intercept, and it's going to have a negative x-intercept, so it's going to look like so. That's the oblique asymptote. And then I also plotted on here the vertical asymptote at x equals 2, right? And that comes from this here. And that probably should have been a dotted line, right? But I'll do that later. Okay, so what's next? Let me see here. We also know that, what about r, the remainder? Now, the benefit of r is that it tells us whether the function is above or below the oblique asymptote when you get far to the right. And that's going to help us graph it. Now, if I didn't do that in class, and this is the first time you're seeing it, you'll have to maybe pause, rewind, and take a look at this. So here's what we know. we know 8x squared minus 3x plus 1 is equal to this, right? Plus some remainder r. Well, r is a constant. So what are the only ways we get constants on the right side? On the right side, the only way we get a constant is we multiply 13 by negative 2. Okay, 13 by negative 2. So how do I get the value of r then? Well, it's pretty easy. The left side, the constant value is 1. That's 1. The right side, I have 13 times negative 2, right? The constants in those two binomials. Multiply those out. Plus the remainder r. Well, 13 times negative 2 is negative 26. So I'm going to have to add 26 to both sides to solve for r. r is then 27. Now we would have the total switching function. So I've got 8x squared minus 3x plus 1 divided by x minus 2. And that gives me 8x plus 13 plus 27 divided by x minus 2. What's nice about this is far, far, far to the right, I know that the function is above the asymptote, okay, above. And now we don't have the x-intercepts, but if it's above the asymptote, most likely this curve starts out here above, because it's a plus sign, right? So it has to be above, on the right, that is. So it's going to come along here, probably like this, and go up. And then here, it's going to go underneath and down like so. So I may have two x-intercepts here. Okay, I may not either, because it could be start even lower, right, and do this. By the way, how would you get the x-intercepts for this one? You have to complete the square or use a quadratic formula for that, unless it's factorable, but I'm pretty sure it's not factorable. Okay, so you'd set 8x squared minus 3x plus 1 equal to 0. All right, folks, so if you want to pause, rewind, you can certainly do that if that's helpful. And what I'm doing is you'll notice this is going to be in a Google Sheet and Google Slides, and one page will have the embedded video and another page will have the actual hard copy of the handout here, of the completed, the worked example, I guess I would call it, an example that's been worked out. Okay, have a good day.